have one more in the 18th, Jim Webb from Colby. And then at that point, I'll have a pretty clean list of the new presentation for next year. And while I'm on the subject of next year, let me introduce John Davis, who is one of the junior fellows for next year, 12 to 13. And he will be running the colloquium for next year, the graduate colloquium. And his research is, most importantly, is in cholera in the end of Tsarist Russia and the beginning of, I assume, the Civil War Russia, too.
Right into the 20s.
Civil War and early communist Russia. So we look forward to having you here. And I'll just quickly mention who the other fellows are while we're on the subject of next year, the future. John is coming from Kentucky. You met him. And Natasha Sarkar will be coming from the National University of Singapore, and she is working on plague in turn of the century India. And she'll be a junior fellow. And Dan Royals is a dissertation fellow, and he is at Temple, and he's working on AIDS in Philadelphia in the 1980s. So we will have a diversity of things going on next year. Okay, so right now, today, Michael Liu, Senior CRHR Fellow, is going to present a piece of his work. Mike is a PhD from Pitt in 2000, and has a host of titles: Associate Research Fellow at the Institute of Taiwan History Academic Sinica in Taiwan. He's a chief there, and he's in that capacity. He's also the chair of the Research Group in Environmental History, and a joint associate professor in the National Defense Medical College in Taipei. Received a whole bunch of awards and grants, and has published a long series of articles on early 20th century health and medicine in early 20th century Taiwan, and a monograph prescribing colonization, the rise of medical practice and policy in Japan-ruled Taiwan, 1895 to 1945, University of Michigan in 2009. And this project, which he's getting off the ground while he's here at CHR, is essentially, if his old project was on Japanese colonial medicine, the new project is actually on American colonial medicine. In post-war Asia, really, and it's really about the control of disease, epidemic disease, from MacArthur's headquarters, post-1945, and into the 50s and into the 60s, and pretty much laying the groundworks for the rise of the Japanese economy, the rise of the four Asian Tigers economies. It has all sorts of implications for American involvement in Vietnam, too. This paper today, the title, Disease, People, and Environment, the Plague in China, which will be focusing on his interests in GIS and the relationship of GIS and epidemiology. Comment by Phil Brown, Professor of Japanese History, author of Central Authority and Local Autonomy in the Formation of Early Modern Japan, the Case of the Kago Domain, and a monograph which came out last year from the University of Hawaii on the Warichi landholding system, cultivating commons, joint ownership of arable land in early modern Japan. Phil is very interested in the management of water, and I was at a presentation this morning, which you should have been at, about Bali and the management of water in Bali.
Just cancel my class. You should take out my class.
It might have changed it. It was very interesting. It was all about the management of water in Bali. And he's got a whole, speaking of management of water, a whole new project going on civil engineering, state modernization, and flood control in 19th and 20th century Japan. And is editor of Early Modern Japan Newspaper Journal, and a new book, forthcoming book, on the environmental history of the Japanese islands. So, Michael, it's your show. I'm going to come around that way because there's no room for me over here.
Well, thanks to John. And well, actually, this is not part of my research project here, but before I considered to study the so-called, well, in Taiwan, we call the magical bullet of American medicine after 1945. I need to know what happened before 1945. That means before the magical bullet came in to this region. And before 1945, cholera and plague were two major killers in Eastern Asia, including Taiwan and also to China. And during the colonial period, the Japanese government in Taiwan always claimed we have a filthy neighbor, the China. They are not only invaders by war, but also invaders by bacteria. And plague, epidemic of plague was one of the proof that the colonial government in Taiwan tried to alarm the local society. Well, by knowing the old distribution of plague in China, several scholars, especially historians, using the text records to study these diseases. However, new technology like the GIS analysis came into help in 1990s. So I'm part of training of this GIS technology, so I try to use this GIS analysis to do the job. Okay, well, just show some idea about how GIS can do for historian of diseases. I will click here. Well, since the age of discovery, the world has witnessed important changes in the nature, built, and social environments. New technology introduced to diverse society around the globe have altered the way that disease is transmitted. Dramatic change in the pattern and the distribution of human diseases are inevitable. Actually, this dynamic map was the cases I withdrew from John Hay's book, The Burden of Diseases. The cases were measles, smallpox, and severe diarrhea. John Hay claimed some of the diseases actually followed James Cook's fleet and spread throughout the Pacific Ocean to Asia. And yeah, some criticism to John's assumption, but I just used his cases and his data from his book to draw this map and in the time row to show how his claim spreading the diseases from the coast of South America to Asia. Well, just the tricky that GIS can do. But genetic changes in population occur slowly and do not explain the diseases pattern that shift over years or decades. Comparatively, environmental changes influence diseases pattern much more rapid and through many different pathways or mechanisms. For example, the growth of cities throughout the 1800s created a condition at the beginning of the 20th century in which infectious diseases flourished. Also, improved sanitation, housing, standard of living, vaccine, antibiotic, and other medical interventions led to declines in infectious mortality and morbidity. After Industrial Revolution, human activity began to dominate the world ecosystem. Generally speaking, human activity has altered virtually every aspect of the ecosystem throughout the world. Okay. In most of human history, infectious diseases generally appeared to have been the major killer of human beings before the medical advance of the 20th century. Cholera and plague during the 19th and early 20th century were among the major killers. The transmission of many infectious diseases is linked to biological organisms and the process which may only survive in specific environment. Their survival conditions are especially influenced by fluctuations in environmental variables such as temperature, precipitation, and humidity. The passage of a pathogen from one individual to another is obviously dependent on specific mode of transmission and a particular configuration of various external factors. The World Health Organization has claimed 3 direct effects of environmental variables on vector biology, including temperature, humidity, precipitation, and wind. The 4 environmental factors had a great impact on the outbreak of epidemic plague in China, especially after the 17th century. And certainly, mice, bacteria, and even human beings all took part in the disaster. Now I want to jump to the case study of Chinese plague since the 17th century. This is the picture everybody knows about the assumption of how plague transmit from China to Europe. Most historians of disease believe that in the 1330s, plague erupted in southwestern China. During the 1340s, Mongols, merchants, and other travelers helped to spread the disease, a long trade route to points west of China. It thrived in the trading cities of Central Asia, where domestic animals and rodents provided abundant breeding grounds for fleas and the plague bacillus. By 1346, it had reached the various ports of Black Sea. Okay, the problem is when it became epidemic, or it always be epidemic, never been endemic form. Based on the description of Black Death in Europe, Chinese scholars such as Cao Shuji and Liu Yushang claimed that in the 13th century, Mongolian conquest on Eurasia continent broke an ecological balance, transforming endemic plague in China into a deadly continental-wide epidemic. Both Europe and China lost almost half of their population. Based on that plan, they divided the following 400 years between 18th century and the 20th century to several stages of plague transmission. Because of differences in geographic condition, lifestyle, and socio-economic situation, plague in Yunnan kept endemic while it virtually disappeared in other places of the world. Until the Muslim rebellions in 1856 pushed endemic plague in Yunnan out to surrounding areas and finally caused a global crisis in the late 19th century. However, Carol Benedict has different idea. His book, Bubonic Plague in 19th century China, thinks Yunnan is the origin, and the Muslim rebellion in 1856 played a key role to spread the diseases to China, to Chinese southeastern regions. She listed the Taiping rebellion as an additional factor to the acceleration of pandemic plague, and the Beihai city became the hub for transportation and plague to cities along coastal China. While Hong Kong discovered the first case of plague in 1894, the quarantine system in that island soon caused friction between Chinese community and the British colonizers. Carol's identification are mainly based on modern criteria to identify epidemic plague. Therefore, the cases in her book is much smaller than Cao Shuji and Liu Yushang's books. Cao Shuji and Liu Yushang claimed all the traditional term of plague into the account of bubonic or pneumonic plague. However, the traditional definition of plague in Chinese context was much vague, unlike Carol's use the modern criteria. Carol portrayed the confrontation of colonized and the colonizer in Hong Kong, a friction between modern colonial medicine and traditional salvation by Chinese gentry. Well, both of them think Yunnan could be the pathological origin of pandemic plague. However, the Cao Shuji think the endemic plague already existed in China before 17th century, can trace back to 13th century. But while Carol Bennett thinks the endemic plague kept in Yunnan provinces until late 17th century. After 18th century, the endemic plague became epidemic, but only to coastal China. Not like Chaosuji and the Yushan clan. It already been prevalent in the old corner in China. Okay, several questions were raised between their debate. Based on Chaosuji and the Yushan's claim, in general, the migration followed Mongolian expedition led the road to plague transmission, while the shadow of plague death vanished in the 16th century Europe. China, in Ming Dynasty, almost the same period, will suffer the epidemic till the mid-17th century due to the long-term drought and the social unrest. Migration reappeared in China to search food and avoid massacre, but also carried the vector of plague to every corner in China. However, without modern laboratory tests, scholars have difficulty to distinguish the traditional term of plague, as I mentioned before, the real bubonic plague in China, especially between 13th and the 17th century. Parts of their doubts are also generated by non-typical symptoms of plague in ancient records. That is the risk in Carol Benedict's book. Also, the outbreak of plague before 17th century China clustered, but no significant trails of their transmission. A very different sign to the plague epidemic in the 19th century. The one in 19th century has much reliable evidence to the germ Yersinia pestis because of the lack and slow development of bacteria. About the plague cases, how it be discovered in Hong Kong, well, I also give some reference description in the end of my handout. Carol Benedict's work challenges the position that China suffered epidemic plague before 17th century. She believes that the bubonic plague remains an endemic disease only in Yunnan province, a remote southwest region, till the early 19th century. However, the major factor brought the endemic plague out of Yunnan was the exploitation in mountainous area and the increasing trade to outside, starting in the 18th century. Deforestation could increase the risk of plague outbreak. The clearing of forested land and opening of hill farming in southwest China in mid-1760s favored the survival rate of mice and their interaction with human beings in newly founded agricultural settlements. Furthermore, the Muslim rebellion in 1856 forced the large populations to escape, spreading the endemic plague to epidemic crisis. Rodents, a reservoir for a number of diseases, including bubonic and pneumonic plagues. Their populations are known to fluctuate in response to local and global climate changes. In a warmer environment such as coastal China, rodent population could be anticipated to increase in temporal zone, resulting in greater interaction between humans and the rodents, and a higher risk of diseases transmission, particularly in urban areas. Interestingly, in cool areas, the red flea does not bite humans, but in warm regions like monsoon China, it would bite more frequently. This can result in transmission of rat-borne diseases organisms, although not necessarily through the biting mouth parts of the flea. The population of rats and fleas and then were very essential to determine the risk of plague outbreak, and the microclimates in cities and human settlements greatly increased their population. One of the environmental features in monsoon China is regularly rainy season. During the season, extreme flooding or hurricanes sometimes led to outbreak of bubonic plague. From a case control study in 20th century, A 15-fold risk for disease was associated with walking through flooding water. Plague is in fact an environmental sensitive disease that is carried by fleas, and it is associated with population of rodents. The primary reservoir host of Yersinia pestis bacteria. In coastal China in the mid-1930s, plague bacterial level in rodents have been found to increase in the wake of wet climate condition. Following typhoon or hurricane season between June and September, driven wet weather conditions. Historically, according to Triwin Crossing climate data, during the major plague epidemic of 1891 to 1907, climate conditions became warmer and wetter. It is interesting to note that plague epidemic invaded Japan around 1900. However, the mortality rate in Japan was not as high as in warmer coastal China. The situation probably indicates that the red flea by human lasts in temperate zones such as Japan. Besides these climate reasons, routes of migration and trade play much important role in spreading diseases in China since the 18th century. The transmission pattern of plague epidemic in China varied due to the geographical situation, lifestyle, and socio-economic situation. In Yunnan provinces, now I show where the Yunnan is. Sorry, I should. Well, the red here, this place, the southwest part. In Yunnan provinces, endemic plague moved relatively slow. Because of its remote and isolated geography, the infection usually happened between village and surrounding settlement. The sharp drop in human population of certain settlement would stop or slow down the transmission. Such a transmission pattern changed after the Muslim rebellion in 1856. The rebels flee to other provinces, while more Han people strategically move in and build much strong trading link to coastal China. The disease soon spread throughout China in the 19th century and reached the pandemic proportions due to merchants were frequently moving in and from the country village to a highly populated town. The formation of major city and increased travel, the disease rapidly spread throughout southeast China. The bubonic plague followed the trade routes. The trade route provided access to all corners in coastal China. Now, how can I support the observation I learned from the text records? I try to use the GIS analysis. First thing is to collect the individual data. Well, in the research field of public health, the GIS technology has been exploited for a long time. The public health research has been the forefront using data virtualization tool to convey the complex data to analysis. By using the GIS technology to analyze the historical records of Chinese plague since the late 17th century, the result reveals two roads of plague transmission, north and south, in China before the 19th century, while the case in south recorded earlier. A data set of 72,000 and more information is generated from local chronicles and personal records, such as diarrhea as well as memoir, between 1770s and 1919. To reduce the misdiagnosis of plague cases before the 20th century, epidemiological maps in the 1930s and the 1990s are applied to track down the possible location of the infection. The cases that do not match the acceptable distribution in 1930s and 1990s map are deleted from the data set. 8 maps are produced with an interval of 10 years. Let's check a look. This is the information. And this is the original map. One of the original maps. I use the quote plate because in this map, the data also including the information written in traditional Chinese term of plate before 17th century, which I cannot really identify they were Puvonic plate or mnemonic plate. But Cao Shuji and the Li Yuxiang's research improved that. And this is much reliable plate cases between 1850 to 1990. Then I use this map with the 10 years interval to make this dynamic map. The original case shown in the Yunnan area, Yunnan region, here. And then spread out. This is the southern road of transmission. And please notice that in northern part, just sporadically cases happen. There's no way to link them into an endemic plate. However, in 1910, northern part, especially the Manchuria area, suddenly burst up the endemic, the pneumonic plate. You see, suddenly burst up and linked the northern road of transmission. The origin of northern road, the original plate in northern road is still missing anyway. I just cannot find the origin. But the southern part became quite clear to me. In the very beginning, all cases concentrated in the Yunnan provinces. But to the early 20th century, you can see the cases in coastal China is much greater and bigger than the cases in its origin, that Yunnan area. How we can explain more advanced give the explanation for this situation, and what environmental factor affect the transmission of plate in China. Okay. Then I took the chance to think about the possible explanation statistically. There are several variables we can consider. The first thing is the altitude. As I mentioned before, in Yunnan provinces, when the Han people migrate into this mountainous area, the first thing is they open up the hill land to open up their permanent settlement. That is a totally different lifestyle and the way to open up hill land in Yunnan area. So the altitude could be one of the variables into my equation. And the other one is the transportation. Especially in the coastal China before 19th century, the river system played a main role of transportation. So I took the water system as another variable to calculate that. And the permanent is the cases. And try to calculate the sensitivity among these factors. And that is the equation. Actually, don't ask me that too much. It's provided by economists. I'm not using so complicated one, and someone planned that you should modify that. So, okay. Okay. Then calculate the result shows that. Okay. Well, the cases shows a time difference. The relationship, the correlation coefficient between the cases to the altitude shows the difference over time. In the very beginning, in the very beginning, before the 1865, the relation shows, well, not so great, but still slightly above significant relationship between the cases and the altitude. That is quite reasonable because the cases always concentrated in Yunnan area. This is the high plateau and the mountainous area. However, after the 1850s, well, the correlation coefficient dropped lower than significant level because the cases move out to coastal region, and this is the plain area, and it looks to me the altitude became not so significant for the transmission of plague cases. In opposite way, the cases, the relationship between cases and water systems became more and more clear after 19th century. It supports the hypothesis that the cases actually follow the water or the river system throughout the business transportation of this region. While the Great Canal linked to the northern part and the southern part was abandoned in the same period. So you can see there is no direct connect like this one to the north. And also, it also shows the northern road of plague occurred simultaneously. But where is the origin? As I say, it's still a mystery. Okay, that is the figure. Shows the the distance, the cases, the relationship between the cases and the water. You can see the more close to water, to the river bank, more cases happen, and far the cases low. Well, it seems like I support Carol Benedict assumption, and also probably give more environmental factor to her explanation. However, there's no perfect ending. Well, in 2010, an international team of scientists has found that the origin of plague bacteria by using DNA footprint analysis. They claim the plague pathogen originated in or near China. Then it evolved and emerged multiple times to cause global pandemics. According to the report, the researcher claimed that the plague spread over various historical trade routes in the 15th century. It's later that Cao Shuji and Liu Yizhang planned in 13th century, but much earlier than I and Carol Benedict agreed at the 17th century. That is the date, much earlier than Carol and I suggested. Well, they think the Chinese explorer Zheng He is likely to have carried it to East Central Africa during his travel between 1405 and 1433. That is the map they also used to explain the road, how Zheng He spread out the diseases. Well, certainly the legendary Silk Road, as we already know, also may have provided a pathway for diseases as it did for trade between China and the Western world. However, based on local records and chronicle I have now, no major epidemic plague occurred in that period when Zheng He started his voyage. Also, his fleet had no way to contact Yunnan. This part, it's not close to coastal line. His fleet had no way to contact Yunnan, a remote inland provinces, away from the coastal line. Okay. Oh, by the way, this picture, that is a giraffe. the Zhenghe brought back to the emperor to show where he goes, where he went. And this picture, this painting also is the favorite of a lot of Chinese historians to claim we have our own ages of discovery. Okay. I think with no clear conclusion between mine and the DNA expert, so I think I should stop my talk here. I really cannot solve our differences by using another GIS. Probably someone can help me out in this room anyway. Thank you very much.
I want to talk a little bit about the broader context, academic context of the work and the environment in which Mike is working. I think some of this is going to be familiar to most of the audience, since most of the audience is graduate students who are reading other things that are not available to other people. So some of this, I hope, is going to be going beyond what you discussed when you met with Mike earlier today. The first thing I want to stress is that this work is part of an expanding literature in history of East Asia and Southeast Asia. It's moving in two directions here, actually three. The first is the development of environmental history in this area. The most recent scholarship that people are likely to be aware of is Mark Eldon's book, The Retreat of the Elephants, An Environmental History of China. That's received a lot of press. A number of years before that, Conrad Totman's book, Green Archipelago, Forestry in Pre-Industrial Japan, was another example of this kind of thing. And those two works in some ways have set something of a benchmark. There's another one by Robert Marks on disappearance of the tiger in a somewhat later period, a more concentrated period. But I think Mark Eldon's work in the case of China is the better known of these cases. There is an increased emphasis on this within the context of Taiwan, not just the papers that Mike distributed earlier, but one of the presenters at the conference, it's the foundation for the edited volume that John mentioned, is actually one of the affiliates of Mike's home institution, Hung Wang Ji, who's now finishing up now working on his PhD in history of science at Harvard, and is currently doing research in Hokkaido. He's also looking a lot at environmental history and the impact of environmental policy. That said, I think it's fair to say that the study of environmental history is something of a latecomer to East Asia. At least when people got together in 2009, a group of environmental history organizations, the International Consortium of Environmental History Organizations, which held meetings in Copenhagen and Malmo that year. It was clear that East Asia was underrepresented, and as a result of that, a new organization was developed, the Association of East Asian Environmental History, which held its first annual meeting last year. Its next meeting will be in 2013. That's trying to pull together what had been rather individual efforts or some sporadic organizational efforts. For example, Oxford University funded seminars that looked at comparative environmental history of Japan and Europe. They actually take the theme in the East Asian context somewhat more broadly than that, so that there were colleagues from Beijing Normal University, Mei Shui-Ching, who was working at that point in European environmental history, actually. But there are efforts of this sort that have produced publications, but publications in English are still limited, and I think even within a Japanese language or a Chinese or Korean language context, they're still relatively new. And I think that's a reasonable conclusion. There's also an expanding interest in the spread of infectious diseases in East Asia. A couple of weeks ago, Marta Hansen's presentation was certainly one indication of that. Just to take one other example, one of the predecessors to the graduate students here, Sumiko Otsubo at Metropolitan State University in Minneapolis-St. Paul area, has been working on the transmission of influenza in the early 20th century. But I think in both of these cases, both Marga's case and in Sumiko's case, they're working with fairly traditional research tools and approaches. In that sense, methodologically, they're rather traditionalist, and I want to kind of emphasize the kind of pioneering and frontier level work of the kind of thing that Mike and his colleagues at Academia Sinica and elsewhere are doing. I mean, these allow us to look at the spatial relations associated with disease in rather new ways. In some cases, they provide ways to pose new problems that we haven't talked about before. And certainly in what Mike has presented in his paper and in talk today, stress a couple of new perspectives. And first of all, although we've got a connection between the spread of the plague and the Islamic regions, he's, as I understand the presentation, basically reversing the roles. It's not a question of Islamic people fleeing the area. It's a question of Han people moving in there as a part of conscious encouragement of trying to settle this area with Han people to stabilize the area in some sense. The second issue is that some of the potential ecological implications get reversed by this migratory policy, and although water is still the vehicle of transmission, the vehicle of transportation. Again, the mechanism is different than what most of us presume. When we talk about transportation networks, we typically think of disease moving along operational trade routes that are functioning for economic purposes, whereas this one we're talking about functioning somewhat more as a purpose of political subjugation in some sense, so that although the route is the same, the inspiration, the drive is different. And that comes out of trying to fit this pattern of spread of disease into a geographical and spatial context in a more sophisticated and structured manner than traditional methodologies allow. What I want to do is talk a little bit about the development of GIS as a tool for historians, because again, that provides a context for some of what Mike is doing. But I'm not sure if people in the room are aware of it, but OSU has a major role in the development of GIS. The two people who I think are most closely associated with Dwayne Marble, who's a professor emeritus of geography. He was one of the instrumental people here, and if you looked in the footnotes to the article on GIS history that graduate students were reading, his work is some of what's mentioned there. The other is Joel Morrison, who headed the Center for Mapping, the OSU Center for Mapping for some time, and there are other people who've been involved in developing this as well, in looking at space-time relationships. Meipo Kwan, especially looking at kind of daily activities and their spatial representation, has been a real innovator in this area and won a great deal of recognition for it. If you want a good general introduction, one that I think is somewhat better than the article, the chapters on GIS in John Wilford's The Map Makers really does go out, and it's eminently readable, which one of its real virtues, I think. This provides some kind of context for giving you a sense of some of the technical issues that are involved here. Technical issues that Mike didn't begin to introduce. The whole question of our thinking spatially tends to be conditioned about what we can presume based on our modern use of maps and the trust and faith we have in those documents. You don't realize what a complex, joint, interpretive effort a map is. A map is a visual essay. It's making an argument. We're not always attuned to that argument, but that's what's going on, and it's built on a whole set of assumptions about how you model the Earth. And when you work with data, you've got to figure out a way to reasonably have your data fit within a choice of models. So this is really a critical issue, and I want to talk a little bit more about that in a moment. But in addition to this orientation and association with OSU, the use of GIS is a growing focus within East Asian and Southeast Asian studies in a variety of ways. Now, Mike hinted at this when he talked about the role of GIS for medical work. And that's part of the reason that UNESCO and a number of other government organizations fund an annual conference called the Pacific Neighborhood Consortium, in which GIS applications to a whole variety of policy issues are encompassed. A major segment of that includes historical GIS and its relationship to environmental history and environmental studies. So we're talking about a major government-funded effort that has implications for historians and support for historians. It goes beyond what I think we see in the American and maybe even European context. This is also the focus of a growing set of publications on the possible role of GIS. This particular example came out 2 weeks ago. It's the first effort to show people how you can use GIS to analyze history. It's done by a group of Japanese geographers. John forgot to mention, he asked me to remind you that this is on your assignment for next time you meet. You're all expected to read this.
Oh, really?
Oh, you mean you're not prepared to do that? No, I'm not. I wonder why. The newness of this is something that geographers in particular are interested in. It's telling that there's only one historian in this collection of essays. My essay. Everybody else is a geographer, so they have a missionary sense of zeal about this. But I think there's good reason for this. Yeah.
May I add that there are several compilations of GIS history essays in English.
Yeah, but mostly not written by historians. You think of Anna Knowles-Burt?
No, most, yeah, and she's got 2 of them, in fact.
Right, she does.
But most are not written by historians, and they, as far as I know, really don't cover much in the way of East Asian anything.
No.
But if you were interested in the topic and wanted to look at something that is not in Japanese, there are places to go.
But the Japanese stuff is better.
I wouldn't know, I haven't read it.
Well, you'll have to take my word. One of the things that's come out about with lots of this is, and this goes back to the early efforts to use GIS in a historical sense, is that there are some important limitations to the methodology. One of the things that was initially a huge issue was trying to show change over time. Now, the use of the dynamic, what Mike has called the dynamic map, the use of the movie is something that people are doing more and more. And what you find is that even when you map out assumptions that are built into existing literature, you can come to different conclusions. My first and most, and I still think the most dramatic example that I saw of this was colleagues in Australia who mapped out assumptions about the relationship between the Khmer and the Siamese empires over the course of 1,000 years. And Southeast Asian historians have basically been writing and assuming that when the Siamese empire expanded, the Khmer empire was contracting, and vice versa. In fact, when you put this all down on a map and you are forced to identify the assumptions and look at how this plays out spatially, that's not true at all. They're not always contiguous. There are times when they open up space in between them, there are times when it closes up. I mean, it's a much more complicated picture, which, at least as one solution to thinking about integrating time into a GIS context, is really very stimulating and thought-provoking. Working with this forces us to really clarify what our spatial assumptions are, and because of that we can discover things we never imagined before. And partly that's happening with what Mike's doing. It's exemplified by what we're talking about with the case of the Southeast Asian empires. There are problems in dealing with anything that's fuzzy. You know, you have to identify where things are going to appear by pixel. You know, and pixels aren't fuzzy. They're very concrete. And that's a problem. And it butts against a different issue, and that is that our concept of how space is divided up doesn't necessarily apply in the past. Mike can use point data, that is, specific cities and locations. It's not trying to thread missiles through windows. Okay, so a degree of error is tolerable. It's still a useful mechanism for doing this. But for other purposes, there are some huge issues here. Where do you draw the boundaries of villages? For the most part, if you look at earlier descriptions of villages in East Asia, going back even to let's say 1850, 1860, 1870, there are no boundaries. The officials who are interested in taxing the villages are interested in where are the fields and how much are they worth and how much can I take off of them. Boundaries? Who cares? It's not my business. This is up to the villagers to work out on their own. The same issue comes up in Chinese history repeatedly. It's one of the things that Peter Bohl, who runs the China Historical GIS project at Harvard, has confronted, and he's tried to develop alternative ways of dealing with this. GIS can provide algorithms for estimating boundaries or economic reach that can be used as a substitute, but we take boundaries for granted. We're unusual historically. People weren't very precise in defining boundaries. The boundaries are marked by having access to this town, and whatever trade came into and out of that particular town, and that was very elastic. So this use of GIS forces us to rethink some of the categories we take for granted, and it's perfectly natural. And that's one of its benefits. It pushes us back on first principles in some ways. There's a second problem in the compilation of databases are an extraordinary problem for us. The people who are doing Pacific Neighborhood Conference studies of GIS for medical purposes, they've got databases that modern governments compile for other reasons. Historians have to slog through it themselves. The 72,000 cases that Mike talked about are the tip of the iceberg for this kind of thing. It really is a mammoth project. For a good description, Ruth Mostern's new book, Dividing the Realm in Order to Govern, which is looking at ways in which county-level government, provincial-level government was reorganized over the course of the Sung Dynasty in order to facilitate control. It's a really good example. Look at her footnotes and look at her methodological preface, or methodological appendix, because it's a really good introduction to how much work goes into doing this kind of thing, how much work goes into what looks really simple and straightforward when Mike shows it on the map. There's a ton of work behind this. The use of GIS, as I've hinted, has real analytical value. It's not just eye candy, which is often a common criticism. Mike's conclusions are different because he's using GIS, not just because he's using statistical correlations. The other issues, the other examples I've raised come up here as well. We have to reanalyze and rethink our concepts. It's possible to use the GIS environment as a way to cross-check, double-check, and validate the data that we're using. And very often we draw on multiple sources. Any of you who've talked to Whitney about her prospects and her trying to figure out whether or not a particular source is talking about the same event as another source, without GIS and without being able to plot these things out, you can't do this rudimentary verification of the data. So that at this most fundamental level, this is making an analytical contribution to people's work. This is also a really good way to test standard hypotheses, as both Mike's work and several other examples I've mentioned suggest, but also to discover new relationships. Most of what I've been talking about is trying to find a way to get you to think more broadly about, A, how much work is going into what Mike has presented here, because I don't think it's particularly obvious from the paper or from the presentation, but also to think more about the kinds of things that are possible and the kinds of challenges that are available and necessary to confront when you use GIS. I'm going to stop there.
So let's open things up to either GIS methodology or the bubonic plague, or more broadly. Thoughts about plague?
I was wondering, I know that in the last decade or so, there have been a lot of excavations of plague graves in Europe. And there has been DNA analysis of the skeletons, and it's been confirmed that yes, the Black Death in Europe was Yersinia pestis. I was wondering if any of that sort of research has been done in China, and whether it lends more credence to either the Cowley or Carroll's arguments, if so.
Okay. Well, Chow and Lee and even the Carroll Benedict, they never fully respond to the latest discovery in DNA analysis. The reason why I pick up the cases of 2010 is the research team, including Chinese scientists, especially working in China. However, from the information I got, basically they are only analyzed the cases outside of China from archaeological sites. They haven't really looking into the cases in China. At least one of the references mentioned in their report mentioned, well, the preservation of the archaeological site, especially the core, the body, was not so good for examination. So that is part of make me a little bit doubt for their conclusion.
Mike, when you say outside China, China is an amorphous territory depending on the time. Are we talking about Central Asia or?
Yeah. Well, when I say outside of China, that is by the definition of modern People's Republic of China's boundary.
Right.
Well, what they're doing is they're taking known samples of plague and they're running the DNA on these relatively contemporary examples, and they're doing tree diagrams of how old they are and how connected they are. So they're not. So on the one hand, we do have skeletal DNA from various parts of Europe, most recently London, absolutely 1348, 49, 50, no question. But that data and a series of others are debating about, as most of the DNA analysis takes essentially living DNA and uses the data inside the DNA sequencing to build a history of how that's connected. And really, it's just a matter of how closely related or not closely related things are. And then they have to estimate time distances. So in effect, what that I can't remember the names of those people, but they argue that plague originated in China. Plague originated in its ancient form. It was transferred at point unknown X into the rest of Eurasia and probably underlie the Justinian plagues. Then we leap to the medieval plague, and then we leap to the modern plague. The modern plague is what you're dealing with. So my question is this, because there's a new book by Olo Benedictau called The History of the Black Death. Right? Apparently people have been teasing him for being so modest. But he says, look, let's entertain an alternative hypothesis about the origins of the Black Death in the Middle Ages. Let's forget about the Silk Road, and let's think about, and he proposes that in fact it was a rodent reservoir in behind the Black Sea. If you give me a little more, you're right about here.
Wait, I can give you another.
I need a map. I
have a map.
I
I love math.
You got maps.
Yeah.
But what I'm driving at is, we're essentially here, and it's somewhere in here, north of Kurdistan, a gluten reservoir, and that spread into the siege lines, the Gulf War siege lines at Kaffa, and then it was transmitted into the city, and then hit Europe. Well, why can't the Yunnan, I guess my question is this, if he's right, and effectively there was probably a seaborne, ancient world distribution of the plague into Persian Gulf, Red Sea, and Mediterranean sometime in the ancient world, then this reservoir would have been a remnant of that. It would have burned out except in those rodents. Thus, Yunnan, Carol Benedict can be both right and wrong. Carol Benedict says there's no plague except what's in Yunnan. Well, no. It had erupted many times and it retreated into rodent refuges. The only thing that's not explained by that is the admiral arriving here in 1420 or something, and theoretically, one of these genetic lines comes directly from China in, at a late date. And so they speculate that, and it's in Africa, so they speculate this came from.
No, go ahead, finish your sentence.
Yeah, so it came via the 15th century explorations. But I mean, one of the models that seems to be emerging from the plague stuff is rather than a single disease that marches around, that it ebbs and flows, and retreats into rodent pockets, and then pops up again. And so the story of what happened in Yunnan of Han invasion, some of Peter Purdue's, I mean, basically you're talking about the invasion of the hill country, disrupting a stable relationship with people, and making it epidemic, is not unlike what may have happened up here with World War.
Well, I have asked one of my colleagues working in the National Defense College, asking me how biologists are using the chromosome, actually not the DNA, the chromosome, to calculate the evolution of certain diseases. And he told me that, well, the mutation of chromosome need times. So it used the time period to date back the possible origin. But from his response, it still cannot help you to figure out why everybody identified midnight as the origin of the plague. Because, for example, take the case of a syphilis. We really find a relative virus in South America linked to the syphilis. So we have biological evidence to show syphilis virus actually was mutated from its relative in South Africa and became a very severe disease to humans, while the original form was not so severe. Probably just give you several days fever, then will recover. Could the plague has severe form and not severe form? And we probably need more laboratory work on it.
I was intrigued by the reports about Admiral John Hood's visits to Eastern Africa in the early 15th century,
Yep.
which makes me ask, what do we know, what does medical history know, if anything, much about the history of plague in any part of Africa? Is this much investigated up to now by anybody? Does anybody know?
Well, that is the biggest problem I found in the scientists' report. They just calculate the mutation period of certain viruses and never consider if we can find a solid written records of this case. Well, probably we can think that in this part of India, probably they are, well, I hate to say that, but probably they are barbarian. They don't leave any records. But there's no way.
Well, India is notorious for
Yeah.
records.
No, but Zhenhe's voyage is very important to Ming Dynasty. There's no way this Chinese port doesn't keep any records about the epidemic outbreak or something like that. And I really found very, very rare. And according to the symptom of these cases, actually I can show some of my data. That's possible. This one. Part of the 72,000. I have this kind of X file, probably 20 or 25, like this one. And I just cannot find a single cases look to me in the period of Zhenhe's voyage. Looks to me like plague. They are severe diarrhea. Looks like cholera. They are like dysentery, involving but diarrhea. Diarrhea is not one of the important symptoms of plague.
Right.
So I don't know why.
But the African case is especially prominent from the standpoint of, among other things, as we know, the history of slavery. See, and so you have a you have a degree of immunity in Africa that you don't have in the New World when syphilis goes back and forth and these other things go back and forth. And so
Why not the bubonic plague?
no, not but other diseases. Yeah. But that's why I asked about the plague.
But this, I mean, there is actually this book by, I mean, it's somewhat controversial, but the book about sort of a great catastrophe book by David Key, and he argues that basically climate disruptions or enormous eruption in Indonesia in 536 disrupted ecologies all over the place, including in the ivory trade going up into East Africa, and there was a pulse of rodents as they recovered from this massive drought, which put plague, the Justinian plague, into the ivory trade route through the Red Sea, and kabam, it hits the Mediterranean world in 542. So that, I mean, he's claiming that bubonic plague is in the East African region by 500.
He's wrong
Yeah.
before China,
Yeah,
of
right.
course.
Yeah, right. Now, so, you know, and then these guys, these scientists who have no historical grounding say, well, it must be, you know, of course, what's his evidence? You know, his evidence actually is textual evidence about the spread of the disease, which we now think is Yersinia pestis, into the Mediterranean, up the Red Sea, by various accounts of the trade in those years. So we need a lot more DNA samples.
Yeah. Well, actually, from what I read of their papers, I think they really did a lot of work on calculation of mutation period of
Yeah.
the virus, and then they need a historical frame to mix up them together. So they find the Zhenhe's voyage, the story, but actually that's too. I don't like that.
And dating these mutations, I mean, it gets even more hairy. You get back 5 million years, right? Nobody's really sure whether these mutation rates that they are guesstimating are actually real and they can translate to centuries, or whether they actually change. So the relationships between point A and point B are pretty good. The question is, what's the time depth? The time depth is
Yeah, and the weird thing about Yersinia pestis is it doesn't seem to evolve quickly at all. I mean, we can identify Yersinia pestis in the London cases because it is such a similar microbe to what it looks like today. It is positively identifiable, which is quite unusual in terms of a disease. They usually tend to evolve much more quickly than that. And so the question in the case of Yersinia pestis is, why doesn't it? And if there hasn't been that much change, it makes it that much harder to, I mean, you can look at the spread, yes, it looks different in this region than this other region, but like you're saying, with the timeline, how can you really judge it if it hasn't changed much? But what about, I mean, it had to have developed at some point, so how quickly was it evolving at first, and then did it slow down? I mean, that's something we just don't have any data on, and it's really hard to find because how are you, I mean, the older a body gets, the less likely you are to be able to pull DNA out of it.
Again, this mutation rate business is with that, but we'll just have to see. And apparently there are the plague, I'm pretty sure that we heard recently that plague is being identified in burials in Austria at about 600 or 700 AD. So that's,
Well, usually we count the DNA mutation in generation. And I think the biologists use the 10 generation as a one interval. However, the generation is not only produced every year. In a crowded environment, the mice population would generate more generation in certain periods. So it could be accelerated their production in a crowded urban situation. And according to the investigation done by Rockefeller Foundation in 1930s China, it suggests the crowded environment in southern China will be the highly breeding ground for a lot of harmful animals, including mice. So that will be part of microclimate we should think about. The relationship between urbanization, especially the Chinese living style, and the reproduction of mice in that area.
I'm just curious if there's any information about, I don't know a lot about plague. I've been stuck with cholera for the last 5 years, but about the famine and plague and how that might play out. Is there any correlation with famine?
Okay, I have done some calculation, statistical calculation. It shows flooding has more relationship with plague, rather than famine. I don't know, probably famine, during the famine year, plague is another victim. Mice is another victim, I don't know.
Well, the reason I asked is you're talking about these Muslim uprisings, and I assume there's some pretty poor conditions going on. I mean, as with cholera, you always had, it's usually around war or revolution or something like that. And some of my work in Russia, it seems, it's not conclusive, but it just seems that famine's always present.
Okay, well, although the Chinese scholar and Caravan both claim the Muslim rebels bring out the diseases, but actually they don't have any evidence about it.
Yeah,
the record never says that.
Mm-hmm.
But we do have the document that says the Han merchants suffered unknown diseases when they came back from Yunnan provinces. And according to the symptoms, the document is recorded. It really looks like bubonic.
Can you talk a little bit more about the mechanism by which flooding seems to be propagating?
Okay, this just show in the mathematical relationship. When during the flooding year, especially in the coastal China, there's a seasonal hurricane period, and roughly after half months or 3 weeks, then infection rate of plague would go up. And that is another myth I cannot solve. But the infectious rate will go down every, I think, 2 weeks average before the dry season. That means winter. I don't know why, but just show in the mathematical relationship. But there's no significant relationship between famine drought and the infectious rate.
I mean, one possibility in terms of increased flooding and infection is that rats, fleas, and men are jammed into closer quarters. And the possibility, that and I can't quite imagine why it is that rates would drop off 2 weeks before the beginning of a dry period. However, because floods an extreme condition The second end of that equation is not an extreme condition. And that's an interesting
That's possible
correlation.
explanation. But there's one thing I want to add on sorry about this. The dry season in southern China is not so obvious, I have to say that. It just comparatively,
Right.
it's not so obvious like northern China.
Right.
You said the dry season was also the winter. I mean, because there is a lot of evidence that plague outbreaks are much more likely to occur in the summer, so there would be a drop-off as the weather gets colder.
That could be their biological story.
Right. I mean, it makes a lot of sense that it starts with the floods, but then it happens to, it's not the receding of the floodwaters, perhaps maybe it's the change in temperature on the other end.
Well, there's an interesting pattern in tree ring temperature patterns in English population, which starts, you have a pretty decent guesswork on English population, about 1,200. And you have this great tree ring data, which shows the little ice age starts in the wobblings of summer temperature. And between about 1275 and about 1550, the temperature in the summer kind of is very erratic. And then it gets cold in the summer, 1550 to about 1700. Well, one of the effects of that erratic temperature and moisture in Europe was an enormous famine from too much water, too much moisture, and around 1320, famine, crops were out of the ground, cattle died of rinderpest, and horrors. And so the population started to drop. Then the Black Death hit, and then it continues to hit, and you have these sharp, oscillations in the rate of population growth, meaning downward, more deaths than Earth. Probably the population drops, and these things correlate perfectly with the warm periods. The warm summer periods correlate with drops in population. And then as soon as you hit 1550, 1560, summer temperatures plummet, the population starts to rise. Because it's got to be, because the bubonic plague has been pretty much wiped out by that effect. Then you have the one that fired. Well, that's another whole story.
The nice thing to the southeast China is in tropical zone.
Yeah.
So the temperature changes won't give so dramatic an impact to
But still, so you have this endemic plague for long periods of time, and a little significant from the north. I'd like to know when the plague up in North China and in Korea was there any gaps in the record on the plague that might correlate with very cold summers.
Is Yunnan province at a high enough altitude that it's significantly cooler than the remainder of southern China?
Yeah, and Yunnan province is a very unique geographical location that actually receive weather impact from the Indian Ocean, rather than the Pacific Ocean. So that is the only places in China's territory receive impact from Indian Ocean.
I want to get to the heart of this GIS argument, which is, and correct me if I oversimplify, it's essentially saying that proximity to water replaces altitude as a primary, as a predictor for plague. What makes you, the implication is that altitude is the primary predictor?
Yeah.
And how, could you explain that? Is that true?
Well, from this research, I only do some mathematical calculation, try to figure out which variable is major impact to the transmission. So, well, as you read my article on the about malaria in Taiwan, I use the altitude too. So that is quite common variable we are using to calculate some infectious diseases. Because the altitude will determine the passenger they live, or the vector they live. And also, one of the reasons I think the altitude to be the parameter is, well, the rodent transmitted plague in Yunnan province is different from the species in coastal China. In coastal China, the mice prefer to live with human beings within humans' house. But the rodent in Yunnan, according to the investigation done by the Academy of Science, Chinese Academy of Science in 1990, shows they prefer to live in wilderness. So they come out to my hypothesis. If Han immigrant didn't open up the hill land, will this wild rodent contact human being or not? So that's why take it as available.
So is this, if I could just follow up,
Oh, no.
is this a hypothesis that you think you call this a case study? Is this a hypothesis that
Well,
you can
that's a
generalize
hypothesis.
to?
I use the statistic I have, the numbers I have to try to calculate possible relationship or not. And it only shows there's a possible relationship between the altitude and the cases before 1860. But after that, the relationship, the correlation coefficient dropped dramatically. And it also was the time the plague spread out to the coastal China, and Yunnan was not the only cases, was not only plague that the had the plague cases occurred.
So should we see transportation revolutions across the globe?
Yeah, it looks like to me.
Yeah. Okay.
Is the rodent in the cities then the black rat, Rattus rattus, the one that's most common?
Yeah.
What is the rodent up in Yunnan then?
Well, the rodent in Yunnan is different species. I don't remember its lot in my head, but
There's a squirrel in the Sierras that's got bubonic plague in it. I mean, it's not uncommon that it jumps species.
Yeah, I was really just curious which species it was. I mean, I know that the black rat is through southern China.
like malaria. Different Anopheles would transmit it. But for example, that's from one of my research. The Anopheles sinuses in Taiwan is the major population of Anopheles which can transmit malaria. But the transmission power of this kind of a mosquito is quite weak compared to the same species in mainland China. So even the same species, whatever the rodents or mosquito, may have different transmission capacity in different regions.
Another question that's sort of related to these questions a little bit, but is on the flip side, which is about attempts to control bubonic plague once it came out, and what kind of measures people engaged in, and if there were any geographical differences that might have gone into what the maps look like and how they change over time in terms of attempts to control the outbreak once they happen.
Okay, it shows very different concept in Western medicine and Chinese, traditional Chinese society. We're taking Carol Benedict's book as a case. In Hong Kong, the colonial government, the Hong Kong colonial government, the British government, immediately set the quarantine system and isolation ward. They bring out the plague patient to a ship outside of Victorian Harbor, try to isolate them. But for the Chinese gentry, they think, well, illness and sickness is possible for humans' fate. So they just give them the salvation, even bring them the coffee for them to prepare their funeral. And in inland China, some kinds of a religious paradise was prepared, trying to spare out the devil. And well, I can say that that also inspired me to try to trace down their parade road. Probably the parade road would show that could become the aftermath of the cases. And I haven't completely done that in China. But for the Taiwan's plague case, in 1896 to 97, it matched perfectly. The parade role of a certain god just tried to perfectly match the cases distribution of the cases of plague distribution. But for the study in China, I haven't collected enough information about the parade, and also because the religious parade is kind of a private activity. Not all the official documents were written on it, so I really face some difficulty about it. And that's useless, I have to say.
Well, we have almost 5. One more question? Phil, do you have a question you want to bring up from the Okay. Well, let us put our hands together. Come on. Thank you all so much for coming, and hopefully it's not pouring rain out there. And,
Say stop or not? It was raining? Okay.